Hello grade 12, so we are here again with the paper 1, but now we are focusing on sequence and series. That is in question 2 and question 3 of your question paper. So let's get into it and see how we're going to solve it together. So remember the tips that we spoke about, that every time when you see a question paper, you must be able to then look into what is given to you and be able to answer the question. So here, for example, we are given an arithmetic series, and we know that when they talk about arithmetic series, the first thing that comes to mind should be how to then answer that. So let's do that. So that is our question 2 as we are answering that. So in 2.1.1, they want us to determine the value of T91. Before you can do that, you would have to copy your sequence first, which is 7 plus 12 plus 17 and so on. So what we do with that is we are going to first find our point of A and we are going to find D first. So what happened here is we do have A to be equals to 7 because A is always the first term, and then when we find our differences here, what we do is we're going to say the second term minus the first term, so it's 12 minus 7, which will then give us the number, the answer of that to be our D point. So whatever that you do there, that will be D. So that is going to be 5. And also when you say 17 minus 12, you're going to get 5, which then simple means that you now have your value of D. So D will be equals to 5. So, okay. Before you do anything on this, you need to copy down your formula first, and then let's copy that. Our formula, which you find in the formula sheet, usually at the back of your question paper or in front, depending on what the question paper look like. So Tn equals A plus N minus 1 times D, like that. So let's substitute. What are we looking for? We are looking for T91. So which simple means that we do have the value of N, which is equals to 91. So when we substitute, we're going to have A as 7 plus N is 91 minus 1 multiplied by 5, which is our D, right? Substitute, and then you can just take your calculator. While you're on it, on the calculator, you just multiply it or simplify it. Right away, the answer will then be 457. So that's how you get to the answer of that. But then remember, we are practicing how to write it, and now you need to know where are you going to get your marks. So they will give you marks for a D. Doesn't matter where you write it, even there or there, they will still give you it, the 1 mark for D, and also they'll give you the substitution mark and as well as the answer. So that is how they allocate the 3 marks into the space. So I'm sure you got that one, and it's easy for you to do. Okay, let's move to the second question. There it's 2.1.2. So in 2.1.2, they want us to calculate S91. So, but what you must ask yourself is that, what is the meaning of S? So literally S is our sum, so it means sum, right? So every time you want to deal with S, just remember that you have a formula. So we can just maybe put our formula in a different color here so that you can remember that formula somewhere, somehow. So the formula then will be Sn, which is our sum of all the values of n equals 2. So you need to copy it down so you can be able to substitute n divided by 2, and then we multiply that all by 2a plus n minus 1 in a bracket times D. So that is our formula that you can find in a formula sheet, and you need to be able to then respond or substitute all the things to it. So let's do that. For us to get our S19, we're going to substitute. So we have S91 will be equals to, our n is given to be 91, divide that by 2, and what is our A? The value of A will be 7, so we'll have 2 multiplied by 7 plus our value of n is 91 minus 1 multiplied by D, which we have calculated to be 5 previously. So this is how you would put it down like that. Right away, you just have to use your calculator to get to the answer. In this case, it's going to be 21,112. All right, so that is how you get to the answer. In that context, when they mark, then they're going to give you 1 mark for substitution and 1 mark for the answer. We do not give marks for formulas because the formula sheet or information sheet has been provided to you. So you need to know which formula to use when and when what happened. So that is why they are not giving you marks for that. Then the third question, they want you to calculate the value of n for which Tn, so now they told you that Tn is all equals to 517. So what you're going to do is to copy your formula. Tn equals A plus n minus 1 times D. We are still using the same context. Now you have the Tn, which is 517, equals to our value of A, that is equals to 7, plus we are looking for n, and then we have our D as 5. Then you do your simplification. Remember, what you have to do is just the purely algebra that you must do. First, you will have to subtract 7 both sides, and when you do that, what you're going to get then will be 510. On the other side, when you remove 7, you're going to have your 510 on the other side, and then you're going to have the other value on the other side. So since we are looking for n, that is what is going to happen. So if I minus 7 out of 517, I am going to have 510, and then that will be then equals to, then I can multiply this out because 7 times minus 7 on the right hand side will give me 0, and then I can add this, that will be 5n minus 5. Right, now I need to only be remaining with 5 and with n, whatever that has n. So that means I have to remove this 5n here, but the way we remove it is by adding the opposite sign of that. So it means I'm going to add 5 in both sides. So when I add 5 both sides, I'm going to have 515 on my left, and then on my right I'll have only 5n, because minus 5 plus 5 will give me a 0. Then I'll divide both sides then by 5. We divide both sides by 5. So if I divide both sides by 5, it can show me that n will then be equals to 103. So if you divide 515 by 5 in your calculator, you can check, you will see that it gives you 503 or 103. Okay, so what is the marking there? So marks will be for substitution. So when you substitute by 517 and into the equation, and that's where you're going to get your mark there. How many marks are we given? We have 3 marks. So it is for substitution as well as for the equation. So after you substitute and how you have done the equation, or showing how your equation goes, and as well as what is your answer. Okay, so that's how they give the marks into that. I guess all of us can find those marks. So let's see when I go to the next one, which is 2.2. So in 2.2, we are given a different scenario. If you look there in 2.2, we are told that this is a quadratic number patterns. So this is our key, because then when they say quadratic, in your brain you should have something like an squared plus bn plus c equals 0. So that is your quadratic mindset. So every time you see that, you just remember the quadratic. So we are given that T1 equals 3. So let's write down what is given. T1 is equals to 3. So we are writing that as a term. And we are told that T2 minus T1 will be equals to 9. So if they say T2 minus T1 equals 9. That means that your T1, which is 3, can then be substituted in there. And that means that if you have 3 there, that means that T2 will then be equals to 9 plus 3, which makes it 12. So that's how you get into that. Perhaps we can write it up and then you can see how it's done. So usually this is what I would do, just to try and make sure that I have all the terms properly. So in this case, I'm going to say I was given that T1 is equals to 3, and I was given that T2 minus T1 equals 9, which means that T2 will be equals to 9 plus 3, which is 12, right? The other one I'm given T3 minus T2 equals 21. What will happen then? I'll have T3 to be equals to 21 plus 12. And that will give me 33. So this is the context that I have. I now know what my T values will be in this case. So I know that T1 will be equals to 3, T2 will be equals to 12, and T3 will be equals to 33. So that's how I start my work, right, in the pattern way. Then every time I talk about quadratic, I need to remember that there's no way I can talk to quadratic and don't find the first difference as well as the second difference. So before I even understand what they want me to do, this is very important that I find. So if I say for myself that 12 minus 3, that will give me a 9, as well as when I say 33 minus 12, that will give me a 21. So this is one thing that I have seen, but there's more. So for the second difference, I can then do the same, and I'll find that 21 minus 9 is equals to 12. So that is how I got to that. But I haven't yet looked at any question. Literally, what I have done is just to analyze my first part of the terms. Now I go to the questions. Let's do this. That is 2.2.1. What do they want? To show that T5 equals 111. I can actually use the idea I have here, which I have 3, 12, and 33. Remember, this is going to be my T1, that is my T2, and that is my T3. So I can find T4, and I'm looking for T5. So maybe that is how we're going to just put it down like that. And for the first thing that we did was this, and we were able to find that that will be 9. And if I do the same one as well for the rest, let's see how we're going to get to the other part, because this is the structure we have to use going forward. So when I say 33 minus 12, I did find that was 21. So you can see when I say 9, when I say 12 minus 3, it gives me 9. But if I say 9 plus 12, I should be able to get 21, right? If I say 12 plus 9, I should be able to get 21, and that applies to the rest. If I go up like that, it should be able to give me the other one. So question will be, how do I then get to the ones that are here? How do I know what will be the other values? In normal senses, what you have to do is just to find everything that is possible. In this case, you can also write down that this is 12, right? We said this is 12, so we can write that 12 there, right? Then what will happen is, look, if I say 9, which is this 9, plus 12, that is what gives me actually 21, right? So 9 plus 12 gives me, 9 plus 12 actually give me what? Give me 21. Right. So if I do the same and I just say what will be 12 plus 21. So what will be 12 plus 21? That is the one that is giving me 33. So if I say 12 plus 21, I should be able to get the answer for here, which is 33. But remember that I have to be able to say 33 minus 21, and that also must also give me the sum of 12, because these ones, no matter what, they have to all be 12, because that is the rule, right? So always the second difference is going to be 12. So what for me to do is just to add them like this. So if I add 12 and I add 21, I'm giving 33. If I add 12, if I add 33, I should be able to get the next part that is coming in there. So let's see here. For me to get the next one, which is here, I must add these two. So if I say here, if I say 33 plus 33, it should give me the value of here, which is 66. And in that is the manner for which when I subtract them, I still get 33. All right. So here for me to go forward, if I want to know the value that comes here, I need to be able to say, let's see, 12 plus 33. So I should be able to add this 12 and this 33 for me to get the next term. So when I add them together, they literally give me 45. Now, for me to get T5, if I add 45, which is this 45 here, if I add the 45 and also the 66, I should get T5. So let's add them. That is what you're going to give me 111. Just like that, I have already factorized or find my solution there. So the answer, therefore, will be for me to be able to say that this T5 is actually equals to 111. This is another way. You can use the way whereby you can use your values. I'm just going to write them down. Remember that your first different, which is 2a, will be equals to 12. Your second different, which is 2a, is 12. So you can use this idea, and you can use that one of saying 3a plus b will be then equals to the second one, which is 9. And you have the first one, which is a plus b plus c, that will be equals to 3. So you can as well use this 3 for you to get to the answer properly. So it's not always there's one way of doing this. You can as well use this to get to the answer. All right. So let's see. Now I need to show you how you will get to the marks. So how many marks were given there? We're only given 2 marks. Okay, so they can give you full 2 marks for the answer, or they can give you the 1 mark will literally go for your first difference, or your second difference, I mean to say, for 12, and as well as getting the answer correctly. So that is where they will give you the marks. So in each and every one of these, you're going to get the marks in whatever method that you have used and the way that you have used it productively. All right. It sounded long, but that is because we are teaching. If you practice it well, you will be fine. You won't have to take much time to solve it because it's actually a very easy question for you to tackle. Okay, so let's see the third 2.2.2. They said show that the general term, every time they talk about general term, just be Tn of a quadratic pattern, which I told you it has to look like that. So if a quadratic pattern will be Tn equals 6 n squared minus 9n plus 6. So how do we quickly show that? We can then use the idea that I have showed up there. So this is actually where we are using this part that we have showed here. So you can just come and say, okay, I said that 2a is equals to 12. So that simple means that a will then be equals to 6, because if I divide both sides by 2, I'm actually going to have a as 6. Right. So if I look at this, I always do this. So let's look at it, because you need to do something like this for motivation. I always do this, and I say I have to find what they want. So they want me to find Tn equals 6n squared minus 9n plus 6. When this happened, I'm already now smiling to say that, oh, I'm managing to get some. So when I say a is 6, I have ticked the box. My a is equals to 6. I found that, and that is correct. Okay, so let's check the next part. The next one, we said we're going to use 3a plus b equals 9. So this will help us to then solve for the value of b. So let's substitute our a, since we already have our a as 6 plus b equals 9. So this is supposed to be plus b. Let's write it properly. Then what will happen? Then we can then divide both sides by 6 times 3, which is the value that can go to the other side. So let's do that. If I remain here with b, that will be equals to 9 minus, not even divide, we are minusing it both sides. So that is going to be 9 minus 3 times 3 times 6, which is 18, right? So that is going to be minus 18, which then makes our b to be what value? Remember, we have a target of having a b to be a negative 9, so we need to check that that is actually true. So we need our b to be a negative 9. When we are finding b here, our aim is to make sure that it becomes negative 9. Voila, we actually have got it right. It is negative 9. Then we move to the next one, which is the last one. So we have a plus b plus c equals, what was the value? A plus b plus c, we said is equals to 3. So that will be equals 3, right? Then we substitute what we already have. Our a is 6, our b is negative 9, and we are looking for c. It does come right like that. So what is going to happen here is we're going to move everything from the left to the right, and we remain only with c. So that will be 3 minus 6 plus 9. Then we simplify that, and it should really give us the answer that it should be a 6, right? So that is 3 minus 6 gives us a minus 3, and then we have to add 9, that gives us 6. So that looks like we are at something, because if you check, you will see that this is our 6, and that is the 6 that we're also looking for. So we have actually proven that the equation that they wanted is really the one that we have found, right? So you conclude and say, therefore, Tn is equals to, remember, they have given it to you, 6n squared minus 9n plus 6. In this way, you would have collected the marks that you had here, right? So that's how easy this question is if you focus on it. So how do we put the marks then? Marks allocation will also go to yourself, having to manage the 12 there and having to manage, so all these values would have its own mark allocation, having to manage your way of doing it, whatever method that you have used, and the fact that you manage to equate them together. So you won't get a mark for finding this because this is already given to you. So we'll give you marks for finding the terms, but you show how they were done. You don't just find them. You have to show how they were done and how you found those terms, and that's what we give marks for. All right. We don't just say, okay, you got it right, so let's go. No, you have to show how it's done. Then we'll give you full marks for that. Remember, small thing can get you penalized in examination. So make sure that you look at the small details. All right. 2.2.3, show the pattern, show that the pattern is increasing for all n is an element of natural numbers. They have just brought in nature of roots here, which you need to remember, right? So they want you to remember that. What does that mean when we say things are increasing in nature of root? We're naturally saying that they are positive. Though there's two ways for us to find this. We can actually find the value of n and then we see what it has, or we can use the word increasing in a very good way where we say positive, or we use the greater than instead, right? So we can use either one of that for us to get to the answer that we need. So let's see if I use, remember the formula that we have in algebra that says, or in graphs that say x equals negative b divided by 2a. So this is the one formula that we can use. Just remember that our x is not x but n. So you can use that formula, n equals negative b divided by 2a, and then you just substitute from that equations that we have there, which means that your b will be a negative 9, and you substitute that with 2, and your a is a positive 6. Then use your calculator, you see that n is equals to 3 divided by 4. Right, the minimum value at n, which is equals to 1. So this then shows that we have a minimum value at n where it will be equals to 1, and it's literally showing us that then Tn will be increasing. So it does show that Tn is an increasing graph. So you need to be able to say that Tn will then or is increasing, right? For all the values of n is a natural numbers, element of natural numbers. So you need to be able to say that as well, but you can see how it's linking nicely with other content. So you need to be able to find that up. So what we give you marks here for will be to identify the formula and substitution. So your substitution would be for the mark. And how many marks do we have? 3. So we give for the answer and we also give for the conclusion. So that's how we answer the second question. Very, very easy, but it needs you to know what formula to use and when do you use the formulas. So we have decided to put question 3 and question 2 and question 3 together because they are all in the same topic called sequence and series, and so that you can see how the structure of question paper comes. So for question 3, you can see that it has a different context. So here, for example, you can see that they're speaking about a different patterns. There we're talking about linear, and we also spoke about linear, and we also spoke about, so this is called linear. Arithmetic is our linear one, and we spoke about quadratic, which is this one. But now if you check on the next one, you will see that they are now talking about geometric. So that is another part or another type of sequence and series. The moment they say geometric, yours is to just say, I'm remembering that has to be AR to the power n, right? So geometric has to have AR to the power n minus 1, which is your formula that is on the formula sheet right at the back. And always when you see geometric, remember that you are talking about a ratio. So always remember that your ratio is a small letter r. So those are the important ones. Ratio means divide in the simple context. Okay. Now let's check. Given the geometric series of 3, 6, 12. So usually what I like to do is just to copy what they give me first before I get excited to say I know what I'm doing while I haven't checked. So I have 3, I have 6, I have 12. Since I just said that this is actually geometric and it deals with, so this is my key. I always do that because it's help. Geometric depend on ratio. So that means I need to know that my T2 divided by my T1 must also be equals to my T3 divided by my T2. So that is my slogan or way of doing things. So that 6 divided by 3 must be equals to 12 divided by 6. And that is actually true because you can see that I'm getting 3 in both sides. So that makes, I'm getting 2 in both sides. I mean to say, see, this is what I said. You get excited, you make mistakes. So I'm getting 2 in both sides. So I know that right away my value of R is actually 2, while I already know that my value of A is actually 3. So this is what represents my value of A right away. So I don't have to be told, but I already know that this is A. So I have my R and I have my A. Just like that. Easy, right? So let's go to the question. In 3.1.1, what they want us to do is to write down the general term of this series. Remember I said that we are looking at something like this. Tn equals A multiplied by R to the power n minus 1. Already we have our A and R. So what we do here, if I've already multiplied there, I just simply substitute them here. So I'm going to have my 3 multiplied by, usually R, I like it to be in a bracket because if you have a negative, it's get affected. So that is why I just like it to be in the bracket like that, so that it makes sense. You see how easy it is? When you have done your analysis, it's very easy for you to just collect the fruit hanging marks, right? Then in 3.1.2, they want us to calculate the value of K. They want us to calculate the value of K, provided that this is the information that is given. What does this mean? Actually, if you see this sign, just remember the word sum. So every time you see the sign, there's a sigma notation, you just remember sum. So it means that we are literally have been given the sum of something that is equals to that particular one. So what you need to do then is to just analyze that information that you have and you put it down. So let's write it as they've given us. So we know that the sum at, let's write this sum properly. We know that the sum, where is it coming from, of k, but it's coming from p equals 1, right? For 3 divided by 2, multiply by 2 to the exponent p, it's actually equals to 98,301. So that is what they gave us. This is simply means that this particular thing here, it's actually our TN. So I usually just do that to my student, tell them that this is actually where your TN is, just like that, right? Nobody can tell you, but you need to know that that is your TN, so you can be able to talk to it in that context. All right, but before you can do anything here, you would need to know what is what starting where. Since this is a continuous of the question going this way, so you can still use this because this is actually linked together with that. It's not isolated because this question is a continuously dependent on the information that is given. So this actually simple means that the same thing that we have said there can also be said in a different manner. So we can say that the sum, where it's starting from p equals to 1 as well as ending at k, of 3 divided by 2 multiply by 2p, it's actually equals to 3 plus 6 plus 12 plus many of these which we don't know. So you can actually represent it in this manner because that is what it is when we say it is a continuous thing. All right, and then after that, you can then look at what you have. In this case, you can actually just say your n is the same as your k. So instead of you using the word k, you can actually use n, or you can just know that this is what happened. So, but initially when you see this, because we're talking about the sum, the formula that you are going to use, therefore, it's going to be the formula of sum. That formula is always in your formula sheet as well. You just have to know what formula to use. That formula is always in the formula sheet. So it's Sn equals, remember, this is for geometric series, not arithmetic. So it will be a, and then we multiply that by r to the exponent n minus 1, all divided by r minus 1. You need to know that is the formula you are going to use, and you need to know how you're going to use the formula. Okay, so let's see. Now that's what we know and that's what we have. So let's go and work. Now when we substitute here, remember we know what our Sn is already is. We know that this is our Sn, right? It was given to us. So what we're going to do is just to substitute it into that formula, and then we move, right? So we actually have a, let's write it this way, and then we are going to have, what is our value of r? Our value of r, we have already found it to be 2, right? So we're going to have 2 there, and then to the exponent k, not to the exponent r, no, n, because here is what we are substituting. So this is now going to be our k instead. So we're going to have to the exponent k, and then we minus that by 1. So this is actually the first part, or this part of the numerator. Okay, then we divide this all by the value of r, which we already know it's 2, and then we minus 1. This whole thing will then be equal to 98,301 according to the statement that is given to us, and then this is the information we have. Then initially, that after having this, we'll just have to try and move everything, substitute anything. For example, our value of a, we already know that it was actually 3, because that is the first term that we have. So it's 3 multiplied by the rest. So if we can work it out to see what's going on, obviously the 2 minus 1 will give us 1, so that we can leave, right? So let's multiply in and see. So the first part we are going to have, we can leave this one until we get it right. So we're going to have this part, let's write it properly, 2 to the exponent k minus 1 equals 98,301. Then we can divide both sides by 3 for us to make sure that the 3 has moved, then we can move on. So if I divide everything by 3, then I'm going to have, if I divide this, let's divide it. If I divide this by 3, I'll have to divide this by 3, right? So when I divide it by 3, what am I going to have? I'm going to remain with 2 to the exponent k minus 1, which will then be equals to 98,301 divided by 3. But I need to only remain with what have k. So what I'm going to do now is then to move the 1. But how do I move it? I am going to then add 1 both sides. So I'm going to just add 1 both sides, and that means I'm going to then have 98,301 divided by 3 plus 1. Then when I do that, I'm going to have my answer for the right, if I punch that in the calculator, as 32,768. But on my right hand side, I still have 2 to the exponent k. So when you are here, you can do two things. One, you can use logarithm to take k down, or you can just find the exponential representation of 32,768, which will be the same as 2 to the exponent 15, and this side is 2 to the exponent k. So if we have exponential rules, we can just then come and drop the exponent, then k will then be equals to 15. So that is how you can solve this, either by log, or you can use your exponential rules to get to the answer like that. Whew, that was quite nice, a nice question. I like it. Let's see how much marks we had. Is 4. Of course, it's going to have quite a lot of marks because you have done work that nobody can do in this case, but you're the only one in grade 12 who can do this. So let's mark. The first mark will then go to what you have done in terms of expansion, which is what you have done here to show your skill, that I can show off these things. I know what it means. So they can give you the mark for that. Then they'll give you a mark for substitution as well as using the formula right, but also for the fact that you have analyzed the k as an n instead of just an n. They will give you the mark for that. And then after that, they will then give you the mark for the answer, which is coming to 4 marks. And that's how they simply or quickly get to the answer like that. All right. I guess you guys have seen what you need to do is to know what question you are talking about and what information you need to answer the question. Now, 3.2 is actually different from everything that you have done because it has been separated, you can see. But you still have to go through the same thing. Here they told you that you have a geometric sequence, right? Let's use different colors. You have geometric sequence and you also have arithmetic sequence. So you just have to remember that when you talk arithmetic, you're literally talking a different one as much as when you talk geometric. So you need to remember their formulas and what you need to do. So they say they have the same first term. So both of them have the same first term, but what is happening or what is not the same here? Let's read it. They said for geometric sequence, the common ratio of it is actually going to be equals to 1 divided by 3. So that is important. Then they say for the common difference of the arithmetic sequence, the common difference, which is our d value, remember that is going to be equals to 3. And then they say the sum of the 22 items. When they say that, they're literally telling you that the 22 is n. Please, please, please hold that to your mind. They are telling you that 22 is n. Of the arithmetic sequence, take note, it's actually 734. So what is the 734? That is going to be your Tn. Right, so that's what you need to put down. And they say it's more than the sum of the infinite. So remember, the sum of the infinite will be this one, that you do it in this way. So it's written differently from the one that you already have in terms of what we have worked with. Then they want us to calculate the first term, which the first term is the same. And if that's the case, then we are safe because we can just equate if the first term is the same for both of them. So let's get to it. Right, first let's deal with arithmetic. So let's deal with arithmetic. So we are first dealing with arithmetic sequence. So with the arithmetic sequence, what we are going to do then is to start with its sum. So Sn equals to n divided by 2 multiplied by 2a plus n minus 1 times d. Remember, this is the formula, but then we know that we are looking for s, or we have s22, but then now we know that n is 22, divide that by 2, and we know that we don't know the a, so we're going to leave our 2a as that because that is our term 1, but we know the n, which is 22, so we're going to have 22 minus 1, which will then give us 21, but then we're going to multiply it by the common difference that they gave us, which is 3. So multiply that by 3, and that is how we're going to simplify to get our Sn or S22 of an arithmetic sequence. Okay, so that will be equals to, let's multiply it out with a calculator. Remember, this is a, please don't mistake it. Looks like 9. That is a. Right, so let's multiply that out. We're going to have 22a, because the 2 and the 2 will divide. Then we're going to remain on the other side with plus 693. So this is more like our equation number 1. We have the first equation that we have just created for arithmetic. That's the only thing we can do so far. Then we go to geometric. So we go to geometric sequence. Our geometric sequence then will be, our geometric sequence, we have our S infinity. They didn't say Sn, but S infinity, which you know it's equals to a divided by 1 minus r. So let's substitute. What is our a? Our a value is going to be, we don't know because it's the same. Then we have our r value given to be 1 divided by 3. Okay, so that is what we know so far about these two. But if I add this together and simplify it properly, I'm going to have 3a divided by 2. Now I have my two equations nicely done and saved. So let me just call them equation 1 and equation 2 so that you know what we are talking to going forward. Okay, so now when I have that, remember that we were told that these two have a relationship somehow. So let's read that relationship. We're told that S22, the sum of 22 terms of the arithmetic sequence is, so that means it's equals to 734 more than, meaning plus, right? 744 more than. So normally when you do this, you're going to say it like this because it's 744 more than. So we're going to start with the sum and then we add the 734 because it's more than, right? So this is what they are actually saying. Then we can substitute what we have here. We had 22a plus 693. That will be equals to 3a divided by 2 plus 734. Then we can do the magic, move it both sides. Let's see if I put all the a's on the one side, or maybe let's first find out what needs to be done. Remove the denominators so that we don't have fractions. So this will be 44a, and then this one will be, what is 693? Use your calculator, you find 1386. Then here you remain with 3a, and then 734. If we calculate that, we're going to find 1468. Right. Then we move all the a's or whatever that has a on it to the side or to one side. Right. When I move that, I will have 44a minus 3a equals 1468 minus 1386. Then here I will have my 41a equals 82, right? Then I can then divide both sides by the same number, which is 41. Since I want to remain with a, divide by 41, and therefore my a value will be equals to 2. So that means that the first number there, or the first value, is going to be a 2. So T1 is actually equals to 2. So let's see where do we get the marks and all those kind of things. So to substitute into the formula, that always give you the marks. So please make sure that you write your formula down and make sure that it's substituted in all times. Substituting, you get your marks. Writing your first equation, you also get your marks. And then you have another mark for substituting to the formula of the s at infinity, and then that is 3. We have 2 more to go to. The moment you create this equation where you analyze the scenario, you get your mark there, and whatever that you do up until you get to the answer, that is where we give you the mark, right? So this actually 26 marks. It's actually easy to grab. You just have to know what formula to use when and what it is that you need to understand going further. All right, so this is how you are actually going to respond to any sequence and series questions. You just have to make sure that you understand which formula to use where and what kind of series or sequence you are given. If you need to do many questions, you can get yourself correct the maths code, as it has an embedded AI tool, Musky, to help you in there, and make sure that you have many questions. Any question you want in this topic, you're going to get there. And good luck. I believe in you.